So the idea of the differential that we started talking about in the last several videos, this concept of dx and dy, are kind of just loosely being introduced here in this section. We will use them a lot more in upcoming chapters, and they'll be continually utilized throughout Calculus 2, but they'll be kind of more generally applied and used in Calculus 3, where you start to really understand a lot more about what they mean in a more abstract context. Now I'm going to ask you to go ahead here and to take a look at example number 4 on your own. I ask you to try to go ahead and work through this problem. So pause the video now, and then of course when you unpause the video, you'll see me work through the solutions. Alright, well hopefully you actually did go ahead and try to work through this. I'll go ahead and quickly calculate out everything that we need here for part A. So first we would go ahead and note again that delta x and dx are going to actually be here 3 because I'm increasing from 4 to 7. So that means that delta y is going to be equal to my y value of a value, or my function here evaluated at 7 minus my function here evaluated at 4. Now, of course, if I was to do this, this is pretty easy. This is going to get me square root of 4 minus the square root of 1, and so I'm going to get an overall value of just 1. I can also see here that if I wanted to calculate the value of dy, I would have to go ahead and use my function evaluated at my starting point of 4. That's where I would create my tangent line. And I'd have to multiply, of course, by my value of dx. So my derivative here is going to be 1 over 2 square roots of x minus 3. If x is getting replaced, though, by the value of 4, I'm going to end up with 1 over the square root of 2, or 1 over 2 times the square root of 4 minus 3, and then times the value of 3. So here you can see that I'm going to end up with a total value of 3 halves, or 1.5. Now in part B, I'm just going to be trying to make a sketch of this picture to understand a little bit more clearly what's actually happening here. So I can first think here that the smallest value that I can actually plug in to this square root function is the value of 3. Anything lower, and I end up square rooting a negative, which I don't want to be doing. So my function is going to look something like this. This is my y equals square root of x minus 3. And I can see here that if I'm going from the value of 4 over to the value of 7, I can start to put some different points here on the curve. And I can also attempt to sketch out a tangent line here. So I have my tangent line going something like this. Now I can see that there is a horizontal distance that I've moved. There is a vertical distance that I've moved to get back to the function, and an even longer vertical distance to get up to the function of the tangent line. So now I can go ahead and I can do some labeling. This distance in here is my delta x, which is of course identical to my dx. It's that gap of 3. This distance in here is just going to be delta y, how much the function has changed, whereas the distance here is going to be my dy, how much the tangent line has increased. So hopefully you were able to get some answers like this for part A and a rough picture of something like this here for part B. When it comes to this section and exams, these are the sorts of questions that I would be asking you to do. Can you compute things like dy and delta y and x and dx? Can you understand what this means pictorially? And if you need additional practice with this, of course, consult the worksheets where I have a lot of problems where you can go ahead and try to rehearse these same sorts of ideas.